Welcome. This video is part of our series of videos that are designed to provide an introductory and simple explanation to our product offering. For those of you who work for a major US wireless carrier, please check our LinkedIn user group that is dedicated to the specific equipment that is used by your carrier. In general, we are always here to help, both in the design, in explanation, via webinar, one-on-one, any which way that we can do to help in making our product user-friendly and useful for you on your particular application. Thank you for your attention, and here's the video.
Hello, this is Britt from Optical Zonu. Today we're going to give a brief overview of the eFiberSat antenna remoting over fiber subsystem, as well as its remote user interface. The eFiberSat system consists of an IP67 outdoor enclosure that's located at the antenna and a 19-inch 1RU chassis that's located indoors. The system can accommodate up to 4 uplinks and or downlinks. There are 50 ohm end connectors on the top of this box. All of those are multiplexed onto a single fiber and transported to the indoor chassis. And traffic may be either uplinks or downlinks. All of the traffic is multiplexed onto a single fiber. One may transport a very low phase noise reference clock from the indoor SATCOM modem to the antenna. One may also set voltages on the center pins of the RF connectors to power LNBs and block-up converters at the antenna. So now we'll look at a few of the detailed features on the IP67 outdoor enclosure unit. So the eFiberSat IP67 outdoor enclosure has 4 50 ohm end connectors for connecting to LNBs or block-up converters at the antenna. For each of those 4 channels, there are status indicators, the status and health indicator of each of the channels. Then on the other side of the outdoor unit, we have the 12-volt power input, as well as the single fiber connection to the outdoor unit. Moving over to the Managed RF over Fiber graphical user interface, we see representations of the eFiberSat indoor unit and the eFiberSat outdoor unit within the connection view. It is possible to monitor the outdoor unit from an internet connection to the indoor unit as a result of the fact that we have a Ethernet over fiber data link connecting the indoor unit and the outdoor unit. The Ethernet over fiber data link connecting the indoor and outdoor units is made possible by having an S11 managed switch together with an Optical Zonu SFP pluggable transceiver within both the indoor unit and the outdoor enclosure. And this fiber data link is multiplexed together with the RF onto a single fiber. Earlier, we created aliases. We are also displaying serial numbers. And earlier, using the command line interface, we created IP addresses for both the indoor unit and the outdoor unit. We can see a more detailed status by clicking on one of the icons presented. For the indoor unit, we can click to see detail of the individual transmitters and receivers, as well as the power supply and the S11 switch and SFP themselves. So if we click on the transmitter icon, we can see detailed information about the transmitter within the indoor unit, or one of the transmitters within the indoor unit. We can see various static data about the transmitter itself, its firmware revision, wavelength, and serial number, and the date code that it was manufactured and tested. We also can see various dynamic data for the transmitter, such as the board level temperature, the transmitter optical output power, the laser bias current, and we also have a toggle switch with which we can toggle the transmitter power on and off. Clicking on the receiver icon brings up data on the receiver subassembly within the indoor unit. So once again, static data such as a firmware revision, serial number, manufacturing date code, as well as dynamic data such as board level temperature and received optical power. The receiver slot window also provides a means of setting up alarm limits for high and low optical received power. We can click on the power supply icon, and we are presented with data relevant to the AC power supply. We click on the management and network icon, and we can see status that is relevant to the S11 managed switch within the indoor unit. Clicking over on the SFP tabs, we can see some static data on the SFP. We can see dynamic data on the S11 switch and the SFP optical transceiver, such as board temperature and transmit and received optical power levels. Again, the fiber transmitter may be enabled or disabled, and alarm limits can be set up around the received optical power. The programmed IP address, as well as the firmware version of the S11 managed switch, is shown here. And then for information on the SFP and the OTDR, if enabled, we click here, and we see additional information for the SFP, as well as the means of using and controlling the micro OTDR. We will discuss the micro OTDR in more detail in other videos. So moving over to the outdoor unit, we can click on the transmit and receive icon to get detailed information regarding the optical transmitters and receivers within the outdoor enclosure. So in the outdoor enclosure, we have 2 transmitters and 2 receivers, and those are essentially shown as subslots. To this one transmit and receive slot, we can have up to 4 transmitters and or receivers. In the first subslot, we have a transmitter. Essentially the same status information is provided here as was provided for the transmitter and the indoor unit. One added capability of the fiber transmitters in the outdoor enclosure is the fact that we can add a bias T to supply a voltage on the center pin of the RF connector in order to power antenna elements such as LNBs. We can control via a drop-down menu the voltage that is presented, so that can be 13 volts, 15 volts, 18 volts, and we can also have a 22 kilohertz tone either present or disabled. Click on the second tab to show information on the module that's in subslot number 2, which in this case is a receiver. The receiver presents the same data and options as the receiver of the indoor unit. Click on the third subslot, which is a second transmitter, and click on the fourth subslot, which is a second receiver. Similar to the indoor unit, we can click on the management icon for the outdoor enclosure, and we can see relevant status information for the S11 managed switch and SFP optical transceiver within the outdoor unit. So this has been a brief overview of the Managed RF over Fiber graphical user interface for the eFiberSat antenna remoting solution. Thank you for watching our video. For more information, visit our webpage, www.opticalzonu.com. Thank you.